Hey guys, so I'm home again, but I hopefully should be back tomorrow. Hopefully last class's homework went okay. What I'm going to ask for you is to hold off on questions until I come back. So on Thursday, we'll check both assignments, today's assignment and the previous class's assignments. And then those of you guys who are thinking about doing like a retake, we can definitely plan on doing that or working on corrections during AR on Thursday. So I want to remind you guys about special right triangles. We learned about these in geometry. You might have seen a little bit of them in Algebra 2 as well. So 30, 60, 90 triangles, and then 45, 45, 90. I'm hoping once I review this with you guys, it'll kind of come back to you if you didn't remember them before. So in 30, 60, 90 triangles, the basis of those is that if I know it's a 30, 60, 90, the side lengths have unique ratios here where we call this the leg or the short side. This is 2 times the short side or 2 times the leg. And then this one's the leg times the square root of 3. I'm hoping that seems familiar. You might need to kind of do a quick refresher on that if not, but we'll be using a lot today. So hopefully you'll remember that as we go through this. So in this triangle, if I want to find the missing sides of these special right triangles, if I know the leg is 1, the hypotenuse is always double the leg. So 1 doubled would be 2. And then the other side is the leg times the square root of 3. So 1 times the square root of 3. So the most simple version of this special right triangle looks like this, where I know 1, 2, and square root of 3. So that's going to be used an awful lot in what we're doing today. So like I said, hopefully it kind of comes back to you in case you didn't remember it from geometry. Now this one's a 45, 45, 90. This one's a little bit more straightforward. This one, in a 45, 45, 90, that's an isosceles right triangle. So the legs are the same length. And then we take the leg and multiply it by the square root of 2 for the 45, 45, 90. So again, this is something you guys learned in geometry. I'm trying to review it kind of quickly. So if the one side is 1, that means this one is also 1. Those are our 2 legs. And then the hypotenuse is the 1 times the square root of 2. So just be the square root of 2. So being comfortable with those is something that we're going to use a lot today. So I'm hoping that that's not too far back in terms of your memory. Like I said, we can always review it when I come back on Thursday. Now we're going to talk about, again, when you guys are working with your calculator, that degree versus radians. We're going to get into that today. Now, today you're probably not going to use your calculator for much other than for like maybe multiplying some fractions. So I'm hoping that you're willing to kind of put it aside a little bit as much as we've been using it. The way degrees and radians work here, I'm going to show you guys how to convert back and forth between these. Now we use something called the unit circle. So the way this is measured is if this is 0 here, we start at 0. 0 degrees is kind of the start of our circle. It's kind of maybe a strange spot to start, but that's where we start in trigonometry. And then I would go around the circle this way. So this would be 180 degrees. And then all the way around would be 360 if I kept going. And then so we go counterclockwise. Some other important points would be, so if this is 0, this would be 90. And another one would be 270. Those are some kind of key points. So again, we always go counterclockwise. Now we're going to talk about radians then as well. So degrees is one way to measure an angle. Radians is another way. So that you really probably haven't dealt with much at all before. So if this is 0 degrees, or sorry, 0 radians, sorry, I should say that. Or 0, we're going to call it 0 pi. So radians are dealt with in pies. So this is kind of why pi is so important. So if I go halfway around to this point, that's considered 1 pi. So what degrees is so if it's 180 degrees in radians, it's 1 pi. So this is the same measurement. Those are equal. They go both ways. So then if I go all the way around, if I have a pi and then another pi, this would be 2 pi here. So radians is another measurement for angles. So 360 would be 2 pi. So I'm going to talk to you about how to convert from radians to degrees. These are some like major important ones. So to convert to radians, basically we're going to multiply by the fact that we know that these two are equivalent. So I'm trying to get rid of degrees and I want to switch it to radians. So I'm going to multiply by pi over 180 degrees. The reason why I'm able to do that, so if I want to convert to radians, I'm going to multiply by pi over 180, is because these are equivalent. Pi and 180 are the same thing. It's just like a different language. It's like, you know, like kind of like we talking about log and exponential. So we want to get rid of the degrees, so that's why we put it on the bottom. So what I'm going to do here is take this 120 and multiply it by pi over 180. So what I'm essentially doing is taking 120 and I'm dividing it by 180. So you're going to have to simplify this fraction. So I have 120 pi over 180. Well, quickly I know that I can cancel the zeros. So 12 pi over 18. And some of you guys are good at using your calculator to simplify this. I can tell I can divide these both by 6. So this would be 2 pi over 3. So this is the radian version of 120 degrees. So anytime I want to switch to radians, I can do this fraction. So now I want to switch 45 to radians. So again, pi over 180. So now I'm going to divide those each by 5. So that'll be 9 pi over 36. Well, then I can divide those both by 9. So that'd be pi over 4. That would be 45 degrees as radians. So 210. Again, get rid of those zeros. Can divide those both by 3. So 120 is 7 pi over 6. Now we're going to talk about negative angles, and I didn't bring that up here. I should have mentioned it. Negative angles can happen. We're not used to them because we never had them in geometry. It just means I go the other way. So on this, if I was going this direction, that would be considered a negative angle. So I still start at 0, but if I go clockwise, then it would be negative. And so if we're switching this to radians, we're still going to use it as a negative. So I'm going to drop off the zeros. I can divide those both by 6. So negative pi over 3. So that's switching things over to radians. So that'll be part of your homework tonight. We'll practice that more tomorrow when I am back as well. Now, if I want to switch something over to degrees, I'm just going to flip this fraction over. So now I'm going to multiply by 180 over pi. Sorry, multiply by. Because I want to get rid of the pi in this. So I'm going to multiply by 180 over pi. Now the pi's will automatically cancel. So those are gone. So I have to do 5 times 180. That's 900 over 6. And that works out nicely. It's 150 degrees. And so since I'm switching over to degrees, I want to make sure that I do include a degree measure. So now again, I have a negative angle. That just means I would be going clockwise instead of counterclockwise around my circle. So I multiply 180 over pi. The pi's cancel. I'm negative 180 over 6. And so that's going to be a negative 30, right? So the conversion's not so bad. We're just making sure that we're switching it back over to degrees. Sometimes I do a little bit of canceling here. So I know that 2 can be divided by 180, or 180 can be divided by 2. It'd be 90. So 3 times 90 would be 270. So kind of like, you know, if you're able to do this faster, that's fine. So I believe that's 240 there. All right, I didn't leave myself or you guys much space on this. Should have left you more. Sorry, you might need a separate sheet of paper if you need to. All right, it wants the exact value of this expression without a calculator. So you could put cosine of 60 in your calculator and get an answer. However, I want you guys to see how we use the unit circle for this. So I'm going to draw this on the little coordinate system. So like as if I'm trying to draw a situation here, like using a circle. So I'm going to go 60 degrees. So I know this is 90 degrees. So this is 0. So I'm going to go 60, which is like this. So if that's 60 degrees, I'm going to draw what this triangle looks like. Now, if this is a 60-degree angle, go back up to our 30, 60, 90 triangle up here. So this would be 1, this would be my short side, this would be 2, and this would be the square root of 3. Just from what I know about 30, 60, 90 triangles. So if you guys remember, cosine is CAH. So cosine is adjacent over hypotenuse. So if I'm talking about the cosine of 60, the adjacent to 60 degrees is 1, and the hypotenuse is 2. So I found out that the cosine of 60 is 1/2 just by using this triangle that I know because of special right triangles. Now, you could check this in your calculator if you're doubting me. Cosine of 60 should be 1/2. But I only want you to use your calculator to check it. I want you guys to kind of not depend on your calculator for this. Now, sine of 45. So I'm going to draw it this way again. You might not understand why I'm drawing it this way. It's going to make more sense when we get to the back side of the notes. So 45 degrees. So this is 90, this is 0. 45 would be right in the middle here. So this would be my angle. Now, in this case, this is a 45, 45, 90 triangle. So I have to go up to the one on the right up here. This would be 1, this would be 1, this would be the square root of 2. So if I'm talking about the sign, that's SOH, S-O-H, it's going to be opposite over hypotenuse. So 1 over the square root of 2. Now the only thing is we don't like square roots on the denominator. I don't know if you guys remember that from Algebra 2, but we don't like that sitting in the denominator like this. So in order to get that out of the denominator, we're going to multiply by the square root of 2. So this becomes the square root of 2 on top, and then square root of 2 times square root of 2 is square root of 4, which is just 2. So the sine of 45 is square root of 2 over 2. Now, if you put this into your calculator will give you some crazy decimal, sine of 45. This is the exact answer. So again, if you want to check that, you could check and make sure they match if you kind of doubt that I'm, making this up or something. All right, let's try this last one here on this side. Tangent of 30. So 30 degrees would be like a smaller angle going this way. So I make my little triangle here. Now if this is 30, using my special right triangles, the opposite, so 30, my short leg would be over here. My adjacent leg here, so my hypotenuse would be a 2, and then my adjacent leg would be the square root of 3. So the tangent of 30 is TOA. So in this case, I do opposite over adjacent. So 1 over the square root of 3. So I can't leave it that way again, just like we didn't over here. So I'm going to multiply the top and bottom by the square root of 3. So there's the tangent of 30, and we got an exact answer without even grabbing our calculator. So take a minute, check those out. Like I said, if this is flying over your head, we'll do a few more, and we can always bring questions on Thursday. This is kind of seems obscure right now, I'm sure. I'm gonna pause the video right now because I can't upload such long videos.